Good evening to one and all. In previous classes, you may have discussed about batteries in locomotives, both conventional and three-phase locomotives. Why battery is so important means from cold start means if loco is in off condition, if we have to start loco, its electronics, everything, battery is very much essential. From battery voltage only, we are booting everything, saving the time, everything, battery is required. So battery is very much vital, and without this battery voltage, loco cannot run at all. So to keep this battery charged and work the loco in a powerful manner, we need to charge the battery. That's why battery charger is required. There lies the importance of battery charger. From one by one, which type of battery is used in three-phase locomotive. Last day we have discussed. Then what is the importance of battery charger? Then how battery charger works. Then different types of failures in battery charger. Everything we will discuss and cover in this session. Okay. Now, before 2 3 days, Raghu sir may have described what type of battery is being used in three-phase locomotives. It is nickel cadmium battery. Its reaction, its anode is nickel oxide hydroxide. Then cadmium is the negative electrode, cathode, and potassium hydroxide electrolyte is used in this battery. Its capacity is 199 ampere hour. That means if this battery is giving 1 ampere, it can give its full power supply extended up to 199 hours. If the load circuit or loco circuit is taking 199 ampere, it will drain out completely in 1 hour. That is the capacity or ampere hour capacity of the battery. So, in order to keep this voltage, its nominal voltage is 110 volt as we all know, and it consists of totally 26 batteries, and each battery is carrying approximately 3.6 voltage, and each is having 3 cells included in it. So keep this 199 ampere hour at 110 volt potential. We have to charge this battery frequently whenever the loco is in energized condition. So we are setting up a 12 kilovolt battery charger in the locomotive to keep this battery energized. Since our population is ABB mostly, we will deal more with ABB circuit. I will explain ABB circuit initially. From that, we can slowly learn different configurations and different types of chargers are there. CGL MAC we are using, ABB Leroy type we are using, ABB type we are using, then MEDA type we are using, Hyrec type also we are using, BHEL type also we are using. All we will discuss one by one. Initially from ABB, the basics I will describe, then we will slowly move on to one by one, different types of charges, its configuration, different modes of charging, everything we will discuss. So, for three-phase locomotives, the CLW specification is this one for battery, and 3.6 volt battery will be there, each consisting of 3 cells and total 199 ampere hour charging capacity. And the charger design is based on German standard DAN, it is called. That word is in German language, and so the abbreviation is like that. Then what we have discussed, basic unit is ampere hour. Means it represents the amount of charge a battery can deliver over time. That means a 1 ampere hour battery can supply 1 ampere current for 1 hour. Simply consider a water tank. Its volume is suppose 500 liters. It is called its capacity. Similarly, 1 ampere of current it can store and deliver for 1 hour. Same concept only, water tank concept. We can remember everything. And above that, the charging rate also I can tell. Means in our homes there will be water pumps. It will be filling the battery, not battery, water tank. If its capacity is 500 liters, if we are giving 1 liter per hour, it will be filled in how much time? 500 hours. That is called C rate. It is applicable for charging and also for discharging. Means how much amount of or how much volume of charge or how much volume of current we are pumping into that battery. That is called its C rate or how much discharge it is happening from battery, that is also can be told as C rate. That is also one major unit which we are using in battery terminology. Okay. Then simple calculation, what I have told, current into time. We all know this one for capacity. Then energy basis also we can calculate. In this, simple difference is voltage is also included. In our case, 110 volt is the basis. Okay. Why I am telling all this means different charging modes. If I want to introduce you, you must know the basic terminologies. That's why I am telling this much detail. Then this one, only few people may be aware about this. All batteries, if it is fully charged, and one more time is the state of charge. In our mobile phones, we can see at top portion how much percentage the battery is charged. If 100% means, suppose a 500-liter water tank is there, it is consisting of 500 liters of water. Similarly, our battery also, if it is fully charged, its state of charge is called 100% at that time. Okay. If our water tank is having only 250-liter capacity and its water content is its half, then its state of charge or how much charge is available or how much capacity it can deliver is 50%. Similar concept is used in battery also. Then second thing, this battery, suppose it is a 110 volt battery. If its state of charge or amount of charge present in it is 100%, then the terminal voltage will be also 100, 110, and the amount of power which it can deliver, it will be also equal to its ampere hour capacity. But what happens when some charge is consumed or state of charge is reduced to some value after some time of usage? Understood? That I am explaining means when the battery is 100% fully charged, its voltage will be almost 109.2 volt. Okay. Near to 110. Then for some time we have consumed power from that battery and state of charge has become 90%. Then its terminal voltage will be 105%. That is 105 voltage instead of 110 voltage. That means in the life cycle of that battery, whenever the state of charge is 100 and it is getting consumed, as the state of charge drops, the voltage which can supplied by the battery also goes on dropping. Okay. Means if a battery is 110 volt rated battery and its state of charge is full or 100%, then only it can deliver 110 volt supply and full current. If its state of charge is less or some power we have consumed means, then it cannot supply the full 110 volt. Its output voltage across the terminal will keeps on dropping. So this fact why I am telling means, as per RDSO rules or design rules which are followed from CLW initial Mikas locos onwards, the voltage up to which the locomotive can work is clearly defined. Okay. So that if battery's state of charge is fully charged means the loco can work, no issue, because the voltage is nearly 110 volt. If the voltage drops up to 92 volt, 92 means around we can see here, that is battery charge has consumed up to nearly 40%. Then the loco will give a warning message, battery voltage less than 92 volts. Once we have seen or LP has observed this message, immediately he will or he should ensure that battery charger is working. One thing. Second thing, the MCBs related to batteries are available in loco, that we will discuss in later slide. That is all in on condition and battery charger is working. Otherwise, if this voltage keeps on dropping further and if it reaches 86 volt, again message will come and immediately 82 volt message will log and loco will shut down. So if it is in between middle section somewhere, unless and until one relief loco comes, we cannot do anything. That is the issue. So in the LP point of view and troubleshooting point of view, Every time when DJ is closed, after few seconds, the terminal voltage which we can see in driver display unit or battery voltage meter is available in the cab. Both of it should be observed by LP or whoever is testing the loco. If it is not rising for some time and otherwise some message is popping up means surely we should be cautious and within few minutes or few hours. In case of conventional locomotives, it will be few hours. It can withstand without battery charger working. But in case of three-phase locomotives, maximum half an hour to 1 hour only we can withstand the loco without working of a battery charger. So don't allow the voltage to drop till 92 volt and below. Before that, we must ensure that every DJ closing, after that a few seconds, the voltage which was initially there, either the UBA meter, battery voltage meter, or DDU reading must rise above 100. Okay. Up to how much it will rise depends on the what is the state of charge condition of the battery and what is the current terminal voltage of the battery. If that rise is not observed, then that should be informed. If required, relief loco can be asked. That is the importance of this terminal voltage value and state of charge and whether to observe battery charger is working or not. Okay. Then modes of charging. While design itself, standards are given us the charging modes of IU0U. This is also one standard. This is also derived from that German Institute of Standards, DAN. And three modes are there, which is used in the battery chargers working in our locos. And first one is this one, I. This terminology is similar to these three. Okay. First one is I means current. This is a symbol used to represent current. In that, initially, if the state of charge is very less, means we have to charge the battery immediately. At that time, lot of current has to be pumped to battery for making it state of charge nearly to 100% or up to 80%, at least up to 80%. It will be working in I mode. I mode or it is also called boost charging mode. Both are similar only. Okay. That means if loco is still or not turned on for some 2-3 days, then the terminal voltage due to marker or RTS, it will be dropping to very down value, nearly 90 volts, like that. At that time, the state of charge will be very less, and at that time, high current charging or boost charging is very much essential for the battery. Okay. For that only this I mode or boost charging mode is used. Okay. Suppose that the battery is charged for some half an hour, loco is working normally only. The voltage or terminal voltage, both terminal voltage and state of charge has raised. So that now there will not be a dip in the condition and the condition is almost stable. Then it will go for U0 mode. U means it is a term used to denote voltage. U0 means in that the voltage will be kept constant. And as the terminal voltage of the battery slowly increases, the current consumed by battery keeps on reducing up to the state of charge reaches nearly 90 to 95%. That mode is called float charging. Okay. U0 is almost equivalent to float charging mode in this. And the final mode, U mode, is now the terminal voltage of the battery has reached almost its nominal value, that is about 110 volt. And almost it is getting fully charged also, means state of charge has reached nearly 95 or above. In that condition, then actually the battery charger's work is to give what all load which is consumed by locomotive and the charge which is required, which is only a few value which is required to maintain the potential of the battery and state of charge of the battery. That current will be actually very less. That mode is called trickle charging or finally U mode. This is the mode of operation of battery charger. Okay. So initially when the state of charge is very less, we need only what? Maximum current should be given and the battery should be boosted. That is called boost charging. Second thing, now the state of charge has crossed above 80%. Now we can work somewhat. So voltage will be kept constant and current keeps on decreasing as battery charges. And final one is whatever there which is only required to compensate the battery voltage which is supplied to the loco also. For that only very little current is required. That is the final mode. It is, or it is called trickle charging. And in actual concept, one more is there. If battery is fully charged and no load is also consumed, then the drop will be only due to the internal resistance or small losses which is incurred in the battery. For compensating that, a current which is also very much less than this value will be only sufficient. But that is not included in this. Okay. Then what I have explained is given in this slide. Slides later I will share. Then overview of the circuit. First I am explaining with the ABB type so that we can understand other makes also simply, and our most of the population is ABB also. So input stage means for operating battery charger we need some input voltage. That voltage is derived from auxiliary converter or bar. We know that three auxiliary converters are there. Out of that, bar 3 or auxiliary converter 3 is giving output to battery charger. That is 415 volt, 50 hertz output. And one more thing is there. This 50 hertz output keeps on changing. When our compressor ramping up or ramping down is there, that time this frequency and output voltage of bar 3 keeps on reducing and then increasing. At that time, battery charger will not be in working mode. Okay. After completing the ramping up of bar 3, then only the battery charger will start working. And its nominal output is 415 volt, 50 hertz supply. Okay. In case of bar 3 failure, load sharing will be happening and bar 2 will do the function which was done by bar 3 previously. Okay. So in case of both bar 2 and bar 3, the output is common 415 volt and 50 hertz output supply. When that supply is ready, then only battery charger will start working. Okay. Now the input side we are having what? 415 volt, 50 hertz supply. Then what is required? Actually battery charger is DC. So we are having three phase AC with us. We have to convert it into DC. So rectification process is required. So the initial stage is input rectifier. Then input choke and DC link capacitor. Means this three phase supply which is coming from bar will be having lot of ripples and we need to hold this power without more fluctuation. For smoothing its current voltage and to give a constant supply, second stage we are having input choke and DC link capacitor for a smoothing the DC. Then this output which is generated by the rectifier, initial stage rectifier, the voltage will be much higher than what? Our requirement of 110 volt. Because 415 volt if rectified will be giving value of 415 into root 3 times. It will be nearly 600 plus voltage. But for charging battery we need 110 volt only. So we need DC to DC stage conversion. Okay. For that next stage is coming. That is single phase full bridge IGBT inverter. It will convert this DC into high frequency AC. Okay. Then galvanic isolation means the bar output means that is a high power and high voltage circuit. And our battery and battery charger is fully what? DC operated and it is dealing what? Some control circuit, electronics, PCBs and all. So if some fault occurs in secondary side, means battery charger side or control circuit side, what will happen? Since bar is a high power source, if short circuit something will happen, the control circuit will be fed with huge amount of power. That is one thing. Second thing is voltage levels are also different. Voltage level means this is 415 volt side and output side is 110 volt side. So huge amount of voltage difference is there. If some short circuit, earth fault or something happens, this secondary side or low voltage side, DC side, will be subjected to heavy voltage also. So it should be what? Isolated. So to provide that galvanic isolation, transformer is used. How transformer will isolate? Transformer is transferring power through induction, mutual induction process only. So there won't be any physical contact between this 415 volt side and secondary side. So in this way, by inducing a transformer in the circuit, we can bring galvanic isolation. Okay. Then it can also avoid, in case of some fault, circulating current like that problems also can be avoided by this galvanic isolation. The next side is, here we converted AC to DC, means this was three phase AC, three phase AC to DC, which is at a higher voltage level. Then again, it was converted to single phase AC, high frequency AC. But what we need? We need DC. So again, we are going to one rectifier. For what? For reducing the voltage level, transformer is there. And after that, we again need what? DC. For that, output rectifier is used. Then output side also, for avoiding the ripples and all, again output LC filter is used. Now we will come to circuit. Before that, some protections also I can tell. Since IGBT is coming in this circuit, some pulsing protection means, in case of if IGBT is misbehaving, or it is, instead of pulsing intermittently, if it is continuous pulsing, for that one gate drive unit card is there. It will be monitoring all these parameters and will be protecting. Then voltage is being monitored, deceiling voltage is being monitored, output current is being monitored, everything is getting monitored. So everything is equipped with protection. Then temperature protection is also there. Then CT is there for current protection, that I will explain later. Then this is the nominal rating of the battery charger, which I have already told. Then temperature sensor is also PT100 sensor, using that it is incorporated in this. And they are claiming that the output ripple will be less than 5%, like that. And 110 amps is its capacity, and 12.1 kilowatt is its power rating. Okay. Coming to loco side, first the bar output will be introduced to battery charger through one MCB called MCB100. In most of the locos, this will be available at the side of bar 2 and 3, and some other shell locos and all, we can see this in SB panel. Our locos, this is located in fully side of bar 2, 3 box. Okay. And the three phase output from bar is fed to battery charger through this MCB100. Okay. Next, what goes inside battery charger, I will explain. Then its output should be gone to where? Battery. But battery is placed at the bottom side of the loco in two separate boxes. So from battery box, near to the battery box, positive side one, 112 MCB will be there. It is at the undergear portion of the loco, covered by that stainless steel box. And this will come to loco in SB panel. In that panel, two MCBs will be there. One MCB 112.1 will take the battery power out to the locomotive circuit, and the charger output 110 volt is connected to this battery and fed to the battery through this MCB 110. This will be the biggest MCB that we can see in the SB panel. And the major mistake that our shed people and LPs are committing, I will tell, to turn on loco, they will turn on this MCB. It is a natural practice, because most of the people are not turning off this MCB while shutting down the loco. So what happens? He has turned on this MCB, but previous LP or previous shunter has tripped, or previous person who was tested the loco has tripped this MCB, I think. But he may not be listening to that, and he will simply turn on this MCB and continue working with this loco. After some time, what will happen? Even though the charger is working, the output power fed by the charger, since this MCB is tripped, will not reach battery. So battery voltage keeps on reducing. In meanwhile, this time, the battery charger output current is also monitored by locomotive circuit. It will also pop up message that current less than 10 amps. One more message, if some more time we are continuing its operation, it can lead to voltage droppage and loco shutdown also. So always while testing loco, please ensure before starting loco that both of these bigger MCBs which are located in SB panel is turned on condition. Position should be always up. Otherwise, charging will not happen. In few minutes, loco will trip. Sure. Okay. Now hope this circuit is clear. And one more thing I want to point out is negative side, no MCB, no protection, nothing is there. This will be mostly helpful in troubleshooting time, because from this output 2052, then 2050 cable is there. Wherever in VAGO SB terminals we are analyzing that 2050 cable, since there is no protection, even if we have turned off this breaker also, while troubleshooting time, if we are placing our hand means we will surely get blown. So in troubleshooting and maintenance point of view, always ensure that negative side is not isolated. So there are chances for getting shock while working. Okay, that should be kept in mind always. And before handling battery charger also, dismantling, removing everything, we have to ensure that this negative cable is also isolated for safer working. Okay. Then this was given in MICAS based old topology circuit. In that much stages of first rectification, then it was converted into single phase high frequency AC, then again rectification. That much stages were not there. This was previously old GTO based technology used battery charger circuit. First, the output of bar through MCB 100 was stepped down by a transformer. Usually 415 to 88 volt output were used that time. That was stepped down through this transformer. Then it was directly rectified by a three-phase uncontrolled diode-based rectifier. Then it was fed to loco circuit. Okay. This also I will explain in coming slide. This was simple battery charger circuit which was used previously in GTO-based locos. Now CGL and ABB Leroy type VC is also following the same configuration. Okay, this is simple. Failure is very, very, very less because IGBT controls sophisticated parts. Nothing is there in this. Maintenance also very easy, trouble free almost. But now other terms like Hyrect, Meda, ABB's redesign, Classic, everyone is using that topology which I have explained in first slide. This is what I have explained in 2 slides back. This is the full topology. I will explain one by one. This is the bar output, 415 volt, 50 hertz, UVW 3 phases. And previously, it was equipped with 3 fuses, each fuse for each phase. And what happened in our locos, due to inrush current or surges, or when our battery voltage is very low, it was taking very high current. So if any one of these fuse got blown, means battery charger will be permanently not working. So if it happens in line, surely loco will fail. So we have taken earlier technology on MICAS based old locos which was used MCB 100. Instead of this fuse, we have provided MCB 100 so that even if tripping is happening, LP can reset this MCB 100 and loco operation can be continued. So now these fuses are not available in ELSCD locos. We have all bypassed this one. Okay. Next is filter inductor was there. After that, This is uncontrolled diode based rectifier for converting three phase AC to single phase, not single phase, DC. And after this DC, this is DC link. It will be equipped with capacitance and resistance. This capacitance is for storing the power and avoid ripples and fluctuations in power. And four IGBTs are there. This set is called V4 not 1 and this set is called V4 not 2. You have all gone through H-bridge configuration of rectifiers or inverters. Means similar configuration is also used here. For converting this DC to high frequency AC, these four IGBTs are operated simultaneously. I will tell you how. This IGBT and this IGBT will be fired at same time and made turned on. At that time, current will flow through this direction. That is positive half cycle. For negative half cycle, this IGBT and this IGBT will be turned on. That time current will flow in the opposite direction. This is done in a frequency of about 1.2 kilohertz, high frequency AC. So that AC is generated in this winding and this is a galvanic isolation transformer. It is having approximate ratio of 2.66 to 1:1, like that. So the high frequency AC which is generated in the primary winding of this galvanic isolation transformer is fed to secondary circuit, and that high frequency AC is again rectified by a uncontrolled single phase rectifier, which is diode is used in this, and which is fed to loco circuit, that I will explain in coming slide. And here the sensors incorporated are input side voltage is being measured, then DC link voltage and current will be measured, temperature will be monitored, so output of this one will be monitored, and output side here two currents will be measured. One is the total current delivered by it, and which is what is the total current returned to battery circuit. So as to calculate what is the amount of current delivered by battery charger and what is the current taken by load, and second one is what is the current taken by battery, that I will explain in next slide. ഇതൊരു മൊഡ്യൂളിലായിരിക്കും സാർ. It will be mounted in a module. Full that module will be backed up with a heat sink, and MRB ducts are carrying high volume air through that, and that duct will be placed aside that module so that the heat will be exchanged between these components and that backup panel to that MRB airflow. Like that, cooling is ensured in this. So in this, IGBTs is there, discharge resistor is there, everything will be heated. Then this temperature sensor is mounted in that module also. It will be a single box like module like box. In that module, it will be inserted. First to monitor. Idila sir. In the IGBT oda firing will be controlled so as to control the output side current. So with this circuit of output is here. Battery positive will be connected to this portion, and the loco current will be driven from this portion. Okay, and this will be battery negative. So in normal working condition, when battery charger is not working, at that time here battery is there. Okay, now suppose that battery charger is not working, but we want to run the control electronics, baby compressor and other equipments in loco. So battery should deliver power to it. It is happening through this path. Current starts from here, then to loco circuit and return. Uh, and the return current will be through this diode back to negative. This will be the normal conduction path when battery charger is not working. Now suppose loco is energized. Now battery charger has started delivering power to locomotive. Then the path will be from here battery charger output positive. It will be charging battery. At the same time the power required by loco is also delivered by this battery charger. And the return current will be flowing through the this path and this path. So now we can differentiate how battery charger module is measuring. Here one measurement is placed so that total current delivered by battery charger can be measured, and here if it is placed means total current delivered from or drawn from battery can be also taken from it. So the difference will give battery charger current, loco current and total current. Okay, this is how calculation has been made. Only two CTs have been used. With that, all the currents, loco current, battery charger current, current which is drawn from battery, everything can be measured. This already I have explained. Previously we have seen ABB redesign and classic type design of battery charger in last slide. This is ABB battery charger which is used in PR2 or Leroy type VCU locos are there. Newly commissioned 39485 and 494. Both locos are using this configuration only. Simply like Mika's technology, output is stepped down through a step down transformer and the three phase output is simply rectified and fed to loco. Simple. And this is the battery charger module. The IGBTs diodes. Everything will be in this portion, underneath portion. This is the heat sink, black color portion. It will be very closely mounted and pasted with heat sink paste is there. So that the heat which is developed mostly in IGBT diodes, everything will be easily transferred to this black color module. And we can see fins here. These fins will be inside the duct which is fed by MRB, machine room blower, so that the heat which is transferred from this module directly to heat sink will be easily transferred to the air which is flowing, and hence cooling is ensured. This is the DC link capacitor. This is the three phase power connector, and the gate drive unit card like that all come will inside in this portion like that. Okay, and this side also card. This one stainless steel frame is there. Behind that GD card will be mounted, and this is for avoiding electrical interference from the control card. The signals which are coming from the control cards to this card in many configurations will be given by fiber optic cables to avoid EMI. Okay, this is BHEL battery charger. This configuration is slightly different. I will explain. Mainly, it will be having two cards, ACI card and AMC card. Control part also I am telling. The AMC card will monitors all the functions of the battery charger module, and the master of this AMC card or controller of this AMC card will be ACI card. Okay, that card is deciding in which mode it should work, whether it is communicating or not, whether it is working properly or not. That card is ACI card. That is, this card has to communicate to that master card. That is ACI card. Okay. And coming to the circuit portion, initially there will be an uncontrolled three-phase diode-based rectifier. After that, DC link capacitance will be there. Now we got DC, but it has to be what? Stepped down to 110 volt range. That is done by this chopper circuit. So by the controlled operations of this chopper and this inductor, initial cycle this will be turned on and inductor will be charged, and in second cycle it will be discharged. Like that, desired amount of DC is given to battery load. This is the BHEL module. Sir, current seat is see that AMC card, and the rectifier and components like that comes at the bottom side of this one, near to the heat sink, and here will be the LEM sensors will be there, that will be mounted here. And this is CGL based battery charger. Here that output is taken from bar 3, and it will be stepped down with a transformer that is shown not shown in this figure to 88 volt phase RMS value, and it is uncontrolled rectifier is given, and to through a choke it was taken to battery directly. One is CGL battery charger module, and then hierarchy, it is little bit complex. Circuit diagram is also not available with us, so we have made block diagram only to explain. Input side one filter will be there, filter inductor will be there. After that, 3-phase to DC, one rectifier will be there. It will be controlled and manipulated by TT2059 rectifier control card. After this rectifier has developed sufficient voltage, there will be one pre-charge resistor. Why I will explain. So initially while starting, the potential at here will be 0 volt, and the output of this rectifier will be proportional to 415 volt and its RMS value. So initially, if we directly give this supply to DC link, maybe due to heavy current and all, capacitor can buck. So for doing it in a controlled manner, a pre-charge resistor is introduced, and through pre-charge resistor only initially this DC link will be charged. After that, this K406 contactor will be closed. After closing this, means already some voltage has been built up initially through this pre-charge resistor. So the terminal voltage difference between this end and this end will be little bit less. So the inrush current will be limited, and then it can be smoothly worked without any inrush or any other problem. Then here we got high value DC. It will be more than 500 volt, and it has to be stepped down using a IGBT based chopper. Chopper means it will be having some IGBT. It will be controlled by one gate drive unit card, and this gate drive unit card will be controlled by chopper control card, and the entire activities of this battery charger module will be controlled by control card, and one interface card will be there to communicate and sense the instructions and transfer between this rectifier module to control this contactor, chopper, and the entire function of this module. Okay, and after the this will be generating a high frequency DC, and means pulsating. It will be pulsating in 1.2 kilohertz. After that, one isolation transformer for galvanic isolation is provided, and its output will be rectified to produce 110 volt DC output. Okay. And unlike other makes, hierarchy is having not a individual module, it is in distributed manner in the side of the bar 2 3 and back side this different modules, chopper module, this control interface card, everything is mounted in different portions. Approximately from this figure we can locate where each component is mounted. In the side wall, the control card and interface card will be mounted. In the back portion of the full bar chamber, the high frequency transformer will be placed, and behind that airflow will be happening. And at the back portion only, the rectifier, chopper card, everything will be mounted in the back wall, like that. Then Meda battery charger also, only this much block diagram is available with us. because it is also mounted in a enclosed one metal carriage module, and input side also will be similar to that one. Uncontrolled rectifier with LC filter will be there. Then high frequency DC-DC converter will be there, and then it will be stepped up because this DC-DC converter will reduce it to some value, and again a step-up transformer is used to bring it near to the 110 volt level, and again it is single phase uncontrolled rectified and fed to battery. This is the MEDA module. We have to dismantle and see each and every part. Till now we have not got any opportunity or battery charger failure in MEDA, so we have to see further. And MEDA at the bar 23 top end only the battery charger will be mounted like this. Then coming to battery charger failures, almost all major portion of the failure in our shed for 8 session is contributed by battery chargers. Mainly SIVs. Then coming to this 3-phase locos, classic type AB battery chargers are there. That is mainly failing. So here I am discussing featured cases, 3 cases. Last year what we got. This is BHEL 1 30555. This one also battery charger was not working. So I have told one AMC card is there. If that card is not getting plus or minus 15 volt power supply to work, means all our cards, our computer, everything will be having some SMBS. Similar to that, our battery charger control is also controlled by some cards which are driven by some power supply cards. If that plus or minus 15 volt is having some fluctuation, the codes which have been driven to the battery charger control card cannot be properly executed, and it will make the battery charger surely fail. In addition to this, one more thing happened that near to the module bottom side diode, some flash marks was also available in that. Since 2017, we have not opened this module, and after failure, when we opened the module, then only we got the flash marks, and the bolts which are tightening the diode were also in molten condition at that time. So the condition of that one, and here flash mark was there. Above it, DC link capacitors, other sensors, all other things are coming above this module, and this is also a box type enclosure. So at the bottom portion, what is happening we cannot see. We have to unload and dismantle the full module. Then only we will be able to see what is going inside. Then 30540, this is high rec make battery charger. The circuit previously I have explained. In that, multiple problems are there. In February month, we got this contactor was in stuck off stuck on condition alternatively, because it was not a permanent failure. At times this contactor will not work. That has resulted the failure. So that time actually contactor was in good healthy condition only. So the cards which are controlling this one is main is control card, and control card is giving command to open or close this contactor, but it is fed through this interface card. So last time we have changed both of this card, and for a precautionary measure contactor was also changed. But last month what happened is this contactor stuck off message was also there. VCSAT problem. VCSAT means if GDU card is controlling the chopper, that is giving IGBT the command to turn on or turn off, and this card collects feedback from IGBT, measures its voltage, and ensures that whether it has turned on or turned off. That feedback is also given back to main control card through interface card. So actually we were unable to pinpoint, since lot of components are involved in this. Anyone can malfunction, which can lead to full module failure. So vital items which are related to the entire parts of that circuit we have changed, because we were unable to conclude what is the exact reason of that failure. Similarly, 904 loco also staying here since last 2 weeks. In that case also, we were unable to conclude solidly which part has contributed to the failure. If the failure is permanent, at least we can conclude that this item has caused this failure. But transiently, sometimes it will come, after some time it will functions normally. Like that, if problem is coming means we are unable to trace and find what is the exact reason. So doubtful components which may be causing that failure, or all the components we have to replace, like this situation is coming in. So the messages and bar data also related to battery charger, like this red color messages will be taken as valid problems during that time. Through this monitoring, there is a list which all codes corresponds to which fault, what has to be taken care, like that codes will be there. Based on that only we are troubleshooting in this. And in 30725, one more case was there. There is a DC link positive plate will be there and negative plate will be there. Where? At the after the rectifier side. So that plates will be actually, this is insulated itself and will be separated by a minute gap. And this will come in the almost bottom side of the module, and underneath this there will be diodes, IGBTs, everything. So what happened is, IGBT was there like this, and inside IGBT substrate, it will be made by silicon like components only, it will be made. So what happened means, they have used some excess length bolt. So what happened? The bolt will go inside. From outside, when we are seeing, we will see that bolt is not fully tightened. Two things it can cause. It will make the separation between plates different. And second thing is, inside substrate is there. It will go and hit that substrate also. In this, the tightening and washer, when we change the IGBT used, spring washer will be there and flat washer will be there. Spring washer, what happens means, one time if it is used, again it is taken out and connected means, it's that spring property will be lost, and it has created finally the flashover between these plates, positive and negative plates, which is inside. And this has created positive and negative flashed means DC link is short. So sometimes battery charger will work when DC link is built up, otherwise it will not work. So this has resulted in failure. And one more thing is that I have shown one bleeder resistor. Across the DC link capacitor, resistors were there. Why? Because after turning off the loco, in few minutes, that full charge which was stored in DC link should be discharged. That is also monitored by controller card. If that voltage is not discharged or that resistor is having some problem, means again firing will not happen and DC link will not be built up. In such cases, battery charger will not work. One case in 30644 also, that bleeder resistor got opened. So DC link once charged will not be discharged. Till that discharge completes, if suppose a neutral section is there, till that time battery charger was working. But after neutral section, again LP is trying to close DJ. Again in few seconds battery charger has to work. But since DC link discharge is not happening, as a protective measure, it will stop working of battery charger. So battery charger will not work. So that happened in case of 30644 also, got failed. This was that bleeder resistor. കണ്ടിട്ട് മനസ്സിലാവുന്നില്ല. Sir, in circuit it will come parallel to this one. കാണുന്നില്ല. And some 2-3 things we have done is, one already I told that input side fuse was there. If it trips, the only possible solution is to stop the loco. Fuse has to be replaced only after reaching some loco shed. So till that time battery charger will not work. So we introduced MCB 100 for that, And the other one was that I have shown four IGBTs were there. In that IGBTs, V402 and V401 is there. The V41 we observed that it was having less duty cycle as compared to V402 IGBT. So duty cycle means how much time it will be turned on. Actually, in normal conditions, both IGBT should carry equal load or both legs should carry equal load. But in case of V402, it was slightly more. So if more load it is carrying means sooner it fails. Okay. So we identified that the firing pattern for V402 was imposing it heavy duty cycle and it is causing failure of that IGBT and battery charger is getting failed. So we advised ABB to equalize the firing cycle and we have made it almost okay, and now failures have got considerably reduced, and one cycle V402 IGBT, since it was subjected to heavy stress, failed a lot. So we have changed one cycle for that. Now the software has been adjusted so that the firing pattern is equalized and it was almost normal. Then some output ratings which we have discussed initial also, and some protective settings also I will tell. 110 amps is the setting for the battery charger current. If that current goes beyond that value, message will be coming. Charger current I am telling means whatever current which is delivered by battery charger. It includes the current taken by battery plus current taken by the loco circuit. Then DC link over voltage also in ABB it is given as 730 volts protection. If that limit is came means battery charger will trip. Then voltage values, initially I told you warning will be given in 92 volts and 86, then 82 it will shut down like that. Actually in 86 itself we are getting shutdown cases. Then some messages which I have told, contactor open but should be closed like that. This was for Mika system. Normally when MCB100 is tripped or that fuse fails, this message was getting coming. Then battery charger current below 10 amps. That is also when battery charger is not working. Sometimes if battery is fully charged also, this message can come. Now companies like CGL has changed their setting from 10 amps to 8.1 amps also. Because fully charged batteries, if the electronics is taking very less current only, at that time the current consumed from the battery charger will be very less. So at that time also current will go below 10 amps and unnecessary tripping will come. We have observed in 3912511123, we kept it for 3 days fully charged without disturbing it. Same message logged in that locus also. Okay. And voltage is below 82 volts. It is kept at the shutdown limit value as per setting. And the 86 voltage is the final warning before 82 and loco is getting shutting down. And some 2-3 things also before winding up, especially while testing in ABB locos. After loading this 98 software version, there is a huge delay in starting of the battery charger. So PPO people are also giving lot of bookings. LPs are also giving lot of bookings. In other makes, what we are getting is as soon as the DJ is closed, bar will suddenly start working, and immediately within 20 seconds we are getting battery chargers in fully powered condition and it is output it is delivering properly. But in case of ABB type locos, some more issues are there. One is late pickup of the battery charger. It is around taking 30 to 32 seconds for picking up of battery charger. So that is one thing. The second thing is if loco has crossed a neutral section, LP has closed the DJ, then bar started its working. At that time, the MR pressure has dropped below some 8 kg. Suddenly what will happen? Compressor has to be started. For starting compressor, what should be done? Soft starting is required. So again, bar output will be reduced. Means it was previously delivering 50 at 415 volt supply. But for soft starting the compressors, it has to down its frequency till 18 hertz, and voltage level also considerably reduces. So at that time, battery charger can work or not? It cannot work because 415 volt 50 hertz is not there. So till that cycle, the frequency ramping down and ramping up completes, that much seconds, battery charger will be idle condition. Again, this delay will come. So LPs, what they will think? I have closed DJ 1 or 2 minutes over. Now also UBA meter is not shooting, and still the battery voltage shown in BDU is also below 100. That means battery charger is not working. So surely they will be in a situation in which whether battery charger is working or not, that confusion will be there. So ABB is mostly giving this problem. Other makes this problem is not happening because suddenly it will pick up. That is one issue. While testing also same problem is happening. Then popping up is also coming sometimes. That is the software trouble that we have advised to rectify it. That's all.